Hello and welcome. Today we're going to be covering the equations, lesson 1-5, page 33 in your algebra book. We have a few vocabulary terms that we got to discuss before we go in, and then we're going to do examples. So our first two words that we need to know are open sentence and equation. The difference between an open sentence and an equation is one has an equal sign, the other does not. An open sentence does not have the equal sign, an equation does, and that's what separates the two. Alright, a few more terms. Finding a value for a variable that makes the sentence true is called solving the sentence. The replacement value is called the solution. A replacement set is a set of numbers from which a replacement can be chosen, and each number of a set is an element. The solution set is the set of numbers that make the sentence true. That's a lot of jargon right now, but don't worry. We're going to go through and we'll have some examples and it will make more sense, hopefully. Alright, here's our set of our first examples that we have. Find the solution set for each equation of the replacement set, typo there. This right here, this group of numbers surrounded by the braces, is the replacement set. These are our options of what we can plug in to these equations to see which number makes this true. Alright, each one in here, each number inside of the braces is known as an element. Whatever element, when we plug into this equation makes it true, becomes part of our solution set. Let's try to plug some in. When we plug in 0 in for m, we get 8 times 0 minus 7 equals 17. 8 times 0 is 0. Minus 7 is negative 7. Negative 7 equals 17. That's not true, so I know that 0 is not part of our solution set. Alright, next thing we've got to try 1. 8 times 1 minus 7 equals 17. 8 times 1 is 8 minus 7 equals 17. Well, that's 1 equals 17. Again, that's not true, so I know that 1's not part of my replacement set. Let's try 2. 8 times 2 minus 7 equals 17. 8 times 2 is 16. Using our order of operations, remember we still have to do that. Minus 7 equals 17. 16 minus 7 is 9. 9 equals 17. Well, that's not true. So I know that 2 is not not a part of our solution set. I can't talk today, guys. The last one to try is element 3, so we plug that in. We get 8 times 3 minus 7 equals 17. And then we need to solve with our order of operations. 8 times 3 is 24. Minus 7 equals 17. Looks like we might be onto something here. 24 minus 7 is 17. 17 does, in fact, equal 17. So ding, 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 we found our winner. 3 is our solution. That makes that equation true. In our second equation, we have to do the exact same thing that we did in our first. Use that replacement set and plug those values in to see which one makes that equation true. We have 28 equals 4 times 1 plus, and I'm going to plug in 0 first, d. Oh, I said I was going to plug in 0 and then I write a d. How silly. Alright, that should be 0 So then we have 3 times 0 is 0. 1 plus 0 would be 1. And then 4 times 1 is 4. And we could quickly see that 4 isn't going to equal 28. So 0 is not going to be a solution for this equation. Now we have to plug in 1 to this equation, and we got to figure out if 1 will be a solution for us. So we do that, we get 28 equals 4. 1 plus 3 times 1 is going to be 3. 3 plus 1 is going to be 4. 4 times 4 is going to be 16, which does not equal 28. So I know that 1 is not a solution for this problem. Alright, now let's try to move on and put 2 in there. 28 equals 4 times 1 plus 3 times 2 is going to give us 6. 6 plus 1 is 7. 7 times 4 is 28. Looks like we're on to something. 28 does equal 28. Yes, indeed. So in our second equation, we have 2 as our solution. And we could plug in 3 just to make sure that 3 wasn't a solution either. That'd be a good idea. Do that in your head real quick. 3 times 3 is 9 plus 1 is 10 times 4 is 40, and 28 does not equal 40. So 3 is not a solution either. And so our solution comes from the replacement set, and in this instance it's 2. On this equation, they don't give us a replacement set. So I'm guessing we would just say that a replacement set is all the numbers, and we have to find which number will be our solution for this equation, what p will equal. To do that, we need to use our order of operations. So remember a couple videos ago I said we need to understand our order of operations, and we're going to get sick of PEMDAS, but it's going to help us. To find out what p equals, we just solve this equation. When we do that, we need to look at our parentheses first, and inside the parentheses we do have an exponent, and 5 squared is 25 minus 5. Then we get 6 plus over here, and we bring down divided by 2 on this side. This all equals p. Then order of operations says the parentheses, so 25 minus 5 is 20. Bring down 6 plus, bring down divided 2, and that equals p. And then we have an addition, and we have a division. And division comes first in our order of operations, so 20 divided by 2 is 10. Bring down plus 6 equals p. And then it's just a simple addition problem, 10 plus 6, and we get 16. So p equals 16. I always like to write the variable first. That's just how it's done. It looks weird the other way around. Another example I want you to try by yourself is try to figure out what t equals. Pause the video and see what you get. Okay, to solve this one, we need to continue with our order of operations. So p, do the parentheses first. T equals, leave the exponent for now. Leave division for now. And in our parentheses, we have 5 minus 2, which is going to give us 3. Then we need to look at our new equation, and we need to do our order of operations one more time. We have an exponent. 9 squared is 81 divided by 3. And now we just have a division problem. And when you do 81 divided by 3, you find that t equals 27. Like I said, we're going to do a lot of examples today. That's pretty much the rest of the video. Another equation we need to solve In the parentheses, we have an exponent. So 4 squared gives us 16 minus 10 plus n equals 10. 16 minus 10 gives us 6. We have to do that first. It's in the parentheses. 7 minus 6 plus n equals 10. 7 minus 6 is 1 plus n equals 10. Okay, once you get to this point, you have two options. Now you see that 1 plus n equals 10. There's only one number that you can plug into n to get 10 when you add 1 to it. And that would be, of course, 9. So you could just say n equals 9. But if you wanted to double check, you could subtract 1 from this side and get 0 here. And subtract 1 from this side to keep it balanced. So 10 minus 1 is 9. And then this way you would get n equals 9. So this equation only has one possible solution, and that has to be that n equals 9. Any other value and your equation will turn out false. Alright, here's another example that we're going to do. We have n times 3 plus 2 plus 6 equals 5n plus 10 minus 3. On the left side, we're going to distribute the n to the 3 and the 2. Well, 3 times n will give us 3n, plus n times 2 would give us a 2n, plus 6 equals 5n plus, and in the parentheses, 10 minus 3 would give us 7. Now I can combine like terms of my left and on my right. On my left, I have 3n plus 2n. I can combine them because they both have the variable n, and they're both the same degree. So that's 5n plus 6 equals 5n plus 7. Okay, if I stop here and I look at this, I can see that 5n plus 6 is not going to equal 5n plus 7. So if I were to put in, just say an example, 1 for n. On the left I have 5 times 1 plus 6, which gives me 11. And on the right, if I plug in 1 for n, I have 5 times 1 is 5 plus 7 gives me 12. So they're not going to equal each other. But let's say that I didn't realize that when I got to this point, and I kept working my equation. Well, I could do that. I'm trying to get my n by itself. So I could minus the 6 on this side, minus the 6 on this side, and get 1. These cancel out. Okay? And then I'm going to bring down my 5n. And then on my left side, I only have a 5n left. And then I need to get my n's on the same side, so I'm going to minus 5n here, minus 5n here. Well, a 5n minus a 5n is 0, and on this side it's 0. So I could see that 0 does not equal 1. In this problem, and you'll have some like this, no matter what number you put in for n, it's going to come out false. So for this, you would write no solutions. No number is going to work. Okay? That's a special situation you need to be on the lookout for. Here's a long one, but don't let it freak you out. Just remember to use your order of operations. Working from left to right, in our parentheses, we have 2 times 5 gives us 10 minus 8. Okay, times by 3h plus 6 equals, on this side in our parentheses, we have 2h plus h, which would give us 3h plus 6. And I guess I should put my braces in this case when you're going to need those. And then on the outside of 2. Going back to the left in our parentheses, we have 10 minus 8 is 2. That's going to be multiplied to 3h plus 6 equals 3h plus 6 times by 2. We have the distributive property, so I need to distribute 2 to the 3h to get 6h. 2 to the 6, 2 times 6 is 12. Okay. On my left, I'm going to have to also distribute the 2. 2 times 3h is 6h. 2 distributed to the 6 gives me 2 times 6 is 12 equals 6h plus 12. Before I say anything, what do you notice? They are both the same. You should see that. 6h plus 12 equals 6h plus 12. So let's say you didn't see it, you didn't recognize it, and you kept on solving. What would happen? Well, you would subtract 12 from this side because you need to combine your h's, get your h on one side. So you'd subtract from 12 from this side, and you'd be left with 0. 0 here and 0 here. And then you would subtract a 6h here and a 6h here. This is 0 and this is 0. So you would end up with 0 equals 0. That's true all the time. And this is an example of another special situation where all solutions will work. All numbers that you put into this equation will solve it and will be true. Doesn't matter if it's 1 or 500 billion. All solutions will work for h when you plug it in. Alright, let's see what you guys got. Solve this problem on your own. Pause the video, take your time, work through the order of operations, and see which solutions will work for this. If you did it correctly, you'll have 10 minus 7 is 3, because that's in the parentheses. So you'll have 3 left, plus 9g equals, in the parentheses, we have an exponent of 2 squared, and 2 squared is 4, plus 5 would give us 9, plus 36. Now I need to go through and do some multiplication. So 12 times 3 would give me 36, plus 9g on my left side. On my right side, I would get g times 9 or 9g, and it doesn't matter if the g comes first, plus 36. Right away I can stop because I can see something that should be a red flag to me. I have 36 plus 9g equals 9g plus 36. Yes, they're flip-flop, but remember our property says that in addition to multiplication, they can be flipped around. So these two equal each other. I have the exact same numbers, so you should have got all solutions. I told you we were example heavy today, and we are. So here's the last one that you can try by yourself, and pause the video and see what you can come up with. Okay, I need to solve using my order of operations. So I have in the parentheses the x minus 6, but I can't do that because they're not like terms. So I'm going to move on to multiplication. And I do have multiplication. It's the 1/2 distributed to the x and the negative 6. So I'm going to write 5. Okay, 1/2 times the x is a 1/2 x. Okay, a 1/2 times a negative 6, or a negative 1/2 times a negative 6, gives us a positive 3. That all equals 4. Now I need to get the x by itself, so I'm going to subtract 3 from both sides, and I'm left with 5 minus 1/2 x equals, okay, 4 minus 3 gives me 1 on this side. Then I'm going to subtract 5, and I'm going to be left with a negative 1/2 x equals 1 minus 5 over on this side. That gives me a negative 4. I erased some there so I have more room to work at the top, so I'm going to work my way back up at the top. Then to get x by itself, I need to divide by a negative 1/2. And if you remember, dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to multiply by the reciprocal. The reciprocal of that would be a negative 2/1. And then just multiply across. A negative 4 times a negative 2 would give me a positive 8. And 1 times 1 is 1, so 8/1. So my answer is x equals 8. There's a lot of sign switching in the negatives and positives. Make sure that you're keeping the sign what it needs to be so we come up with the right positive or negative. Right? We did a lot of examples today. Hope they helped you. Keep working on it. And tune in next time.